and techniques you would see in a lab for transmission. The important part of this entire timeline is that since the early 2000s, there haven't been many major developments in transformation techniques, and we are using decade-old techniques, meaning that we need innovation, which is the purpose of my project. So another definition, what is plant regeneration? That is essentially the ability of plants to regenerate whole plants from single cells. The pictures you see on the right, I apologize for the formatting, it's a technical issue, but the pictures you see on the right depict the tomato regeneration process, starting from seeds to germination to explants to regeneration to rooting and a whole new plant. My project focuses on automating the cutting of the explants into those sections you see in picture C. So how manual cutting is done currently is that you have a cotyledonary leaf, you cut the ends off, you cut it in half, you plate both those halves in a plate containing new media. This process is very cumbersome when you're under a hood. It can take a lot of time, and the only places where you can get infection are at those cut ends, right? So for the amount of time it takes to cut everything into those sections, which for a student at my level, I'm an undergrad, about 45 minutes to an hour. Our proposed method of engraving would cut down this amount of time to maybe 5 to 10 minutes, and you have more sites for infection because all the engraved lines, which will be highlighted in the next few slides, are possible points for infection and regeneration. The overall goal is to use a carbon dioxide laser to automate cutting and transformation. My project focused on determining the optimal power level for engraving that resulted in regeneration and tissue survival. My project impacts the goal by getting closer to the optimal power level for regeneration, which acts as first steps towards fully automated cutting and transformation. So the workflow we followed for our automated engraving experiments for the entire summer was that we would prepare plant tissue by germinating seeds, growing them to a seedling stage, as you see in the second picture, and plating whole cotyledon leaves instead of cut cotyledon leaves like you would for standard procedure. Then we would engrave them with the carbon dioxide laser. The picture you see on the bottom right is a blown up picture of what the leaf looked like after engraving. All those engraved lines are possible points for regeneration, making this process more efficient. And after engraving, we would observe said engraved portions for regeneration and survival. So for our first experiment,